Kia ora koutou, Reese from QuickSense here, and today we're looking at graphing inequalities. Now, in this question, we're actually given the graph and asked to find the inequality that made the graph, or that describes the graph. And the way that I'm going to go about resolving this, or finding that inequation, is to think of it first as an equation. So what is the equation of this dotted line here, the edge of the shaded area? Well, it's a straight line, so it's going to look like y equals mx plus c. To find this, I need to find c, which is my y-intercept. And we can see that there at -1. So y equals mx plus c, -1. Now the next thing I need is m, which stands for gradient, or rise over run. Now to find this, I need two clear points. So looking at my y-intercept, I've got a clear point at -1, or at 0, -1, and then looking across, I can see another clear point here, and that's at 1, 1. Now to get over to 1, 1, how do I do it? Well, I make a little triangle where I go across, and then I go up. So my run is 1, and my rise is 2. So rise over run, 2 over 1, x plus -1 simplifies to -1, and 2 over 1, well, that's equal to 2. So as an equation, that dotted line would be y equals 2x minus 1, but it's not an equation, right? It's an inequation. It's an inequality. So because it's dotted, y is either going to be greater than or less than, right? Sometimes you'll see y is greater than or equal to, and if that's the case, then you'll have a shaded area and a bold line. But in this instance, it's a dotted line. So the question I'm going to ask to figure out whether or not y is less than or greater than this is to pick a point up here, let's say over here, and ask, is it possible to be greater than or above the line? Is it possible to be below the line? Now the shaded area, we shade out, so that things that do not satisfy the inequality are shaded out. And by going below the line, I'm moving into the shaded area, and therefore that does not satisfy, right? Y cannot be less than, but y can be above or greater than, which looks like that. So y is greater than 2x minus 1. All right, in this harder question, what we're going to have to do is first of all do a little bit of translation. And any time that we have to do this, I like to begin by naming my variables. So an architect is designing a new house for a client, and the client's got some demands, right? They want the house to have at least 4 large windows. So it's going to have some number of large windows. So we're going to go L is the number of large windows, and at least twice as many small windows as large windows. Now, while S might seem like the obvious letter to use here for the variable, I think that S looks a lot like a 5, and you can make mistakes quite easily that way, so I'm just going to call it W. So W is the number of small windows. All right. The other constraint that we have is that the total number must be less than 30. Okay, so let's start writing these constraints down. So at least 4 large windows. So the number of large windows, something 4, is it greater than, less than, right? So L can be 4, and it can be more than 4, right? Because 5 is at least 4, right? 4 and then some. The next one, so this is at least 4 large windows. The next one, at least twice as many small windows as large windows. And at least, right, that tells me that it can be the same. So the number of large windows, let's keep that on the left-hand side, is at least twice as many small windows as large windows. So we got the small on here. And I know that I'm going to be doubling something. And this is when I want to stop and just sort of use some examples in my head. So let's say that I have 10 small windows. So at least twice as many small windows as large windows. So 10 is, well, twice as many as 5. To get from 5 to 10, I have to times by 2. So it's actually going to be, counterintuitively, the 2 is going to be on that side. Okay? And S, right, is going to be the one that is the limit, the constraint on that. So 2 lots of the large windows has to be the same as or less than the number of small windows. W. The last constraint we have is that the total number, so the number of large plus the number of small, has to be less than 30. Oh, less than, not 30 or less. It has to be less than 30. And now what we're going to do is draw these 3 constraints. Okay. So, roughly, it's going to look like this, and we're going to put L on the x-axis and W on the, L on the y-axis and W on the x-axis. Now, L has to be at least 4. So let's say that 4 is around about here. Well, L can be more than 4, right? I can have more, but I can't have fewer than 4. So as I draw this along here, right, it can be 4, but it can't be anything below. So I'm going to shade out this area. So this is the area that I can't have any windows in this area or combination in this area. The next one, so I'll give that a little tick to remind myself I've done it. 2L is less than or equal to W. And the way to graph this is to think about it in terms of y equals mx plus c. So this one here, right, if L is equal to y, right, and W is equal to x, we don't have to do this, but this just makes the y equals mx plus c thing easier. Y equals mx plus c. L is going to be y, right? And then what have we got in front of L? Well, we've got a 2. But I want that to be on the other side, so I divide everything on the other side by 2. So L equals half of W. And you can see there's no C there, right? There's nothing in here to tell me there's a C. So this is the same as y equals half x. Half is the gradient, so if I start here, I go over 2 and up 1, right? So I'll get to 4 at 2, 4. Yeah, so if I draw this constraint, I take a nice straight line through here. It'll look like that. And then I can get my beautiful shading. And we're saying that that number has to be below that. Right? So we're constraining ourselves. All right. The next one, L plus W is less than 30. The way I want to think about this is by finding the intercepts and then drawing a straight line through them. So if L is 0, right, I'm going to find my x, or where my W is, my x-intercept. So if L is 0, then W is going to be at 30 over here, for example. And if W is 0, then L plus 0 is less than 30. Right, we're going to put that 30 up there. I'm going to draw a straight line through here. And then I'm going to shade out, and you'll notice that I'm doubling up on some shading here. And what I've got down here is actually a nice little area which we refer to as the feasible region. And if I find where these lines cross over, I can find the corners or the vertices of the region. If I wanted to know some combinations, I could use this information to do that. But all the question's asking is to draw these constraints.